So this question is from NEST 2021 shift 2. Okay, 2021 second shift. Consider two identical circular solenoids, each of length L, radius rho much less than L, and total number of turns capital N. The solenoids are on the same axis and distance d much greater than L apart. The ratio of the mutual inductance to self-inductance for this system is rho squared n squared L upon d cube, rho squared L upon n squared d cube, rho squared L upon d cubed, and rho squared L upon 2 d cubed. Now, even without starting to solve the problem, if you look at the options, then all of them have this part in common, rho squared L upon d cube. Okay, and n is the total number of turns. N is the total number of turns, so that doesn't have any dimension whatsoever, right? That doesn't have any dimension whatsoever. So what they have done is they have cleverly put it in numerator in option A, denominator in option C, and in option D we have got this 2 in the denominator, and in option B it's a plain one. Okay, it's rho squared L upon d cube. Okay, so keep that fact in mind once we begin to look at the problem. Okay, fine. So you cannot use the method of elimination of options because all options are dimensionally equivalent to each other. Okay, Acha. So we have got two identical circular solenoids of length L and radius rho much less than L and total number of turns L, and they are on the same axis. Okay, so suppose this is our axis. Suppose this is our first solenoid and suppose this is our second solenoid. Okay, those are our two solenoids. They have radius rho length L and distance d. Now we can consider the centers. Anyways, they say that the length is much smaller than distance d, and that should remind you of something. Okay, that should remind you of something. But anyways, I'll tell you what that is. The ratio of the mutual inductance to self-inductance for the system is. Let us first work on the self-inductance part. Okay, let us first work on the self-inductance part. Achha. Now, when it comes to inductance, always remember that it is the constant of proportionality on the current side. Is it clear? So n phi b is equal to Li, that's the standard expression. Okay, so if it is L, then we know that it is self-inductance. If it is M, then we know that it is mutual. Correct? Now, can we determine L? L is equal to n phi b by I. Let's keep n as it is. How much is phi b now? Phi b is equal to b into a. Okay, and now what is b? Mu naught ni. Correct? Mu naught. N is what? Number of turns per unit length, and the solenoid's length is capital L. So I have to take it, and then I. And how much is the area? Area is pi into radius squared. Radius is not r, radius is rho, so rho squared. But let's not forget I. Okay, let us not forget I. So current will get cancelled, and we will get n squared mu naught, pi rho squared by L. Okay, is it clear? That is our self-inductance. Now we need to consider the mutual inductance. Okay, now let us go to mutual inductance. Now how to find the mutual inductance? The formula is the same. And because the solenoids are identical, there is nothing to worry about. the subscripts. Okay, so what is the mutual inductance now? N pi b by I. N is going to remain there as it is, and now comes the main part. Till N be A upon I, everything is same. Now pay attention. Let us keep this N as it is. Let us keep this I also as it is, and let us keep that A part also as it is. That's pi rho squared. Now when it comes to magnetic field, okay, when it comes to magnetic field, you need to remind yourself that solenoid resembles bar magnet. In fact, bar magnet resembles that of solenoid, and therefore the axial field, okay, of solenoid outside the solenoid, that is equal to what? That's approximately equal to mu naught upon 4 pi 2m upon r cube. Raise your hands if you remember that. Mu naught upon 4 pi 2m upon r cube. What is a magnetic moment? Now, do we have an expression for the magnetic moment of the solenoid? Yes. If it is a single loop, then the magnetic moment is current into area. But it has got n such loops, so that will be n I into pi rho squared, because rho is the radius and r is that particular distance. Okay, so now what I will do is I'll substitute the expression for axial field there, and I will see whether things get cancelled. Right, that was the key part. N by I pi rho squared into b, that's b axial, so that's mu naught by 4 pi into 2m upon r cube. Yes, but now should I take r? I should use d there, right? I should use d, because that's the separation distance, d cube. And now the magnetic moment, n I pi rho squared. Okay, n I pi rho squared. Got it. Okay. Now look, the only constant, numerical constant except pi is 2. And there is no chance that any other numerical constant except pi will pop up in our derivation. Which means if we take the ratio of mutual to self-inductance, can I say that it will have 2 in the denominator? It will have 2 in the denominator, yes, and there is only one option which has 2 in its denominator, and that is option D, and therefore the correct option is D. In the actual examination, there is no need to continue after this. As far as this question is concerned, you mark D happily and proceed to the next question. Got it? But now, because we are doing it, we're practicing it, let us try simplifying it and see whether we indeed get that option. We should, and we will. Okay? So you can stop it, right? You can just stop right there. But now let's complete the expression. Mutual inductance. Okay, now need to be extremely careful here. Current, they'll get cancelled. Then 1 pi will also go. 1 pi will also go. Okay, let's start with capital N now. Capital N comes 2 times, so n squared. Then rho squared comes 2 times, so that will be rho raised to 4. Mu naught is there. N has already been considered, rho squared has already been considered, so pi remains. In the denominator, current has gone, 2 has already been considered, pi is gone, so d cube into now 1 upon L. Okay, so this is self-inductance L. Sorry, that's self-inductance L. Okay, self-inductance L. So that n squared mu naught pi rho squared will sit in the denominator now. This part will sit in the denominator. Correct. This part will sit in the denominator. And what will sit in the numerator? In the numerator we will have capital L. In the numerator we will have capital L. Now see what terms are getting cancelled. N squared goes, mu naught goes, pi goes, pi goes. What remains? Rho squared and rho raised to 4. So rho raised to 2 in the numerator remains. What is the answer? Then L rho squared by 2d cube. Is that the option? L rho squared by 2d cube. Yes, that is option D.